Hello everybody, my name is Dongquan Liu. I come from the University of Science and Technology of China. I will give a talk about the development of Faraday rotation measurements in Keda reconnection experiment KRX. Here is the co-authors: 魏新丁、乔峰章、费斌范、龙龙尚、全民路、文哲毛 and 锦林谢。The outline is as follows. First, I will introduce the magnetic reconnection KRX device and the Faraday effect. Second, I will present the result of the magnetic reconnection simulation and forward synthetic diagnostics. Third, I will show my optical path and bench test of interferometer. The last is the summary and the discussion. Ground experiment of the magnetic reconnection has become an important method to study the space reconnection. The Keda reconnection experiment KRX is being constructed to investigate the fundamental physics of magnetic reconnection. The KRX is a linear device. The stainless steel vacuum chamber is 10 meters long and the diameter is 3 meters. The magnetic reconnection is externally driven by a pair of parallel current plates. The density of the plasma is approximately 10 superscript 16 to 10 superscript 19 cubic meter. The experiment region is approximately 1.5 meter times 1 meter. Here is the plasma parameter attic. This is the photograph of the KRX, which is being complicated. The refractive index of left-handed and right-handed light in plasma is different. Interferometers and polarimeters can be developed to diagnose plasma density and magnetic field. We can derive the phase shift equation and the Faraday rotation angle equation. Okay, a 2D PIC particle in cell simulation model is used to study the evolution of collectioners' magnetic reconnection. In this model, the electromagnetic fields are defined on the grids and advanced by solving the Maxwell equations. With full authorism, both ions and electrons are advanced in the electromagnetic field by integrating the Newton-Lorentz equations in our simulation model. We consider a 1D Harris-Sheet equation configuration in the X-ray plane. The ion plasma frequency can be expressed by this function, and we can derive the ion inertial length equal to 0.2 meter. So the reconnection region contains ion interlength long and 5 ion inertial length wide in the X-ray plane. According to the Faraday rotation angle calculation and the plasma parameter, we select 1 millimeter wavelength of the polarimeter and the interferometer to ensure the sensitivity of the measurement on the KRX. Okay, this is the simulation results. This figure presents the evolution of the whole magnetic field and omega IT equal to 10, 15, 20, 25. This is the typical reconnection feature. This figure presents the evolution of the current density and different times. This is consistent with the reconnection current sheet. This figure plots the horizontally varying of the time evolution of the line integral NEBDL in the PIC simulation along the parallel probing beam at different times. From this picture, that the Faraday rotation angle has a positive maximum value and a negative minimum value. When reconnection occurs, the Faraday rotation angle becomes smaller. So if there is a reconnection process in the KRX device, we can see the result like this. According to the unpaid loop theory, the electron density can be calculated by this equation. The S is the area of the central region referred by the purple arrow in figure 2. The NE is the electron density derived by the phase shift as shown in this figure. The calculated current density diamond line agrees well with the average current density black line, so the Faraday effect can be used to measure the current profile and width of the current sheet during the reconnection. Okay, so this picture presents the vertical value of the line integral NEBDL of the reconnection at different times. Okay, the angle of the Faraday effect becomes larger with the proceeding of the reconnection. It can be used to investigate the onset of the reconnection and determine when the trigger will occur. Okay, this figure shows the schematic optical path design about the interferometer and the polarimeter in the bench test. And these are the reflection mirrors, and these are the mesh. These are the mesh beam splitters. Okay, these two pictures is the bench test of the interferometer and the macro this is the micro source. The micro source is the 320 GHz TX custom transmitter and the lambda. So the lambda is 1 millimeter. Okay. This is the this two picture is the mixing signal. The yellow line represents the probe beam mixing signal. The blue line represents the reference mixing signal, and the IF frequency is 1.1 MHz and the pure rate is 1 US. Okay, here is the conclusion and the discussion. In addition to measuring the electron density and the magnetic field, the current sheet width and the trigger of magnetic reconnection can also be inferred from dynamics of Faraday rotation, even with line integrated the characters of polarimetry, interferometer diagnostics. Okay, we select 1 millimeter wavelength of polarimeter and interferometer to ensure the sensitivity of measurement on the KRX. The polarimeter and the further bench test are being completed. Okay, here is the reference. Okay, thank you for your attention.